Hello everyone and welcome. We're taking a look at the 3.4 lesson practice. So we have our little summary page here. So it can be helpful to visualize quantitative data, right? Data that's going to have a number as a value using dot plots or histograms. Dot plots represent each data point as a dot and its value on a number line. Dots with the same value end up stacking on top of another. So here we see there's 3 18s. And histograms on the right group data into these rectangular bins. So the height of each rectangle shows how many values are in that bin. Histograms are often used when there's more data, when we have to show more than just a few dots. So you can see that this first bin goes from 0 to 10. So there's 8 data points that are between 0 and 10. A dot plot is useful for observing the frequency of individual data and the number of points in a data set. Histograms are more useful representing larger data sets and observing the shape of the distribution. Right, so we can see that it goes up high here and then comes down low. That's looking at the shape of the data. Let's look at slide 2 here with our first problem. It says a class made this dot plot to explore how many letters are in their first name. How many letters are in the shortest first name? So that looks like 3. There's a data point here where this first name has 3 letters, and that's our smallest short name. We can see most of the letters have 4, or most of the names have 4. Here's a first name with 10 letters, just to give you an idea of like what these data points represent. Beautiful. Let's look at the next slide. A class made this dot plot, again, number of letters in first name. So Diani says that the most students have 10 letters in their first name. Is Diani correct? So looking at this graph, I only see one student that has 10 letters in their first name. The most students, to me, have 4 letters in their first name. I notice that it is the tallest column in the dot plot. Beautiful. Make sure to get your reasoning, your thinking in here, plug that in, and then push to the next slide. Jaden created a histogram about the number of pets that students have. What is the bin width of the histogram? So if we're looking at the bin width, we're looking at how far does it go for the first bin. We're going from 0 to 2, 2 to 4, 4 to 6, 6 to 8, right? Each bin has a width of 2. So if you have 0 or 1 or 2 pets, you're in this first bin. If you have 3 or 4, you're in this next bin. Perfect. The next slide. How many students have less than 4 pets? So we're looking at this bin is definitely less than 4. And it looks like there are 7 students in that bin. And then we have another bin here that's less than 4. And there is 6 students. So 7 plus 6 gets us 13 students in total that are in bins of smaller than 4. The next question says, what is the number of pets that no students have? So we're looking for an empty bin. We see an empty bin here and here. So it looks like no students have 14 pets. No students also have 9 pets, right? Or 13. Wherever there's the histogram is at a base level of 0. Beautiful. Next slide. A group of 15 people went to a theme park for the day, and each person kept track of how many minutes that they spent waiting in line. This histogram shows their data. Select all the statements that must be true. Okay. One person was in line for at least 150 minutes. So that is looking like this person here We don't know exactly how many minutes, but we know the smallest is 150. It might be a little more than that, so yeah, that looks good to me. 3 people were in line for less than 50 minutes. So less than 50 is going to be this bar and this bar. So we have 1 person and 2 people. And yeah, 1 plus 2 gets us 3 people. Beautiful. Most people spent over 100 minutes in line. So here's 100. So these are people that are over 100, which is 3 and 1. So there's about 4 people that spent over 100 minutes. Compared to less than 100 minutes is 1 plus 2 is 3, plus 4 is 7, plus 5 is 12. So that one is false. 1 person spent 0 minutes in line. It's possible, but it could have been 30 seconds. We don't know exactly what the data point here is for this. We know it's between 0 and 1, but we don't know exactly the amount of minutes, so we would not be able to check that. No one spent exactly 130 minutes in line. So each bin is 25. So yeah, 130 would be here, which there's no one that spent that amount. Good. So we can check those 3. Alrighty. Go to the next slide. Okay. Imani collected this data about the outdoor temperature in degrees Fahrenheit at noon over the last 2 weeks. Would this data be best displayed using a dot plot or a histogram? I would say a histogram, because there are some decimal values. A bin in a histogram would be best to capture this data. That would be my vote. You could try and convince me for a dot plot, but I think just because we have these decimal values for temperatures, that if we had a bin of like 50 to 52, 52 to 54 degrees, that would make more sense as a way to hold all of this data. Beautiful. Vihan is investigating whether there's an association between wearing sneakers and participating on an athletic team. This table summarizes the data collected from the survey of students. Interpret what the 32% means in this situation. So here's our 32%. So it looks like 32% of students surveyed are on an athletic team but do not wear sneakers. Beautiful. We see that, yeah, they're connected to not wearing sneakers, but also they're on an athletic team. So there's our two-way frequency table. Next slide. Vihan is investigating whether there's this association. Is there evidence of an association between wearing sneakers and participating on an athletic team? Something we look at, if we're looking at wearing sneakers, notice that 16% are on an athletic team, 17% are not. So it's not that different. The percentage of students who wear sneakers is pretty evenly split between whether they are on an athletic team or not. We can also look at who don't wear sneakers, and these percentages are pretty similar too. So it's kind of half and half. It doesn't really seem like there is an association between sneakers and athletic teams. It seems like they're pretty split. Beautiful. Okay, let's look at the next slide. We got 2 more here. Which inequality is shown on this graph? Okay, So we see a dashed line, so it's definitely dashed, right? Which means it has to be less than or greater than. So it can't be this one. We also see that it's shaded below, right? So it's going to be less than, which means it can't be these ones. And then if we look at the information we have, we see our y-intercept is 4, and we see that right here. And we also see our slope is up 2 and over 3. Right? We can see we're going up 2, over 3, up 2, over 3. So that one works. Y is less than 2/3 x plus 4. Beautiful. Nice job, y'all. Last one here. What is the median of this data set? So median is our middle number. So you want to make sure it's listed smallest to greatest, which it is here. And then we cross off one on the left, one on the right. And I like to change colors to make sure I'm not missing. Beautiful. And we're either going to get to 1 or 2 in the middle. In this case, lucky for us, it's just 1. So that's our median, that value of 9. Beautiful. Make sure once you're finished with this assignment that you are submitting it into Schoology. And if you have any questions for me or you want to find time to meet, please reach out and we will schedule that. Y'all rock. You're geniuses. Keep working hard and let me know if you need anything. Bye, everyone.